Hello to everyone. In this short video, my partner and I will be describing the project 2109 of the summer of HPC, whose title is Benchmarking High Energy Physics Workloads on HPC Facilities. In this project, the participants have been Miguel de Oliveira Guerreiro from the University of Lisbon and I, María Herrero from the University of Oviedo. On the other hand, the mentor that has been leading us through this project was David Southwick from CERN. As science advances, the technological resources needed to sustain the necessary computing power are also increasing. This is why, in order to achieve the best performance of the different existing heterogeneous architectures, a collaboration has arisen between different pioneering entities in high-performance computing. The members of the collaboration are CERN, the European Organization for Nuclear Research, SCEO, the organization leading the development of the Square Kilometre Array radio telescope, GIANT, the Pan-European Network and Services Provider for Research and Education, and PRAISE for Advanced Computing in Europe. The demand for computational resources related to high-energy physics has been growing over the last few years. This type of calculation requires many workloads and have different requirements in terms of their hardware. Then, how can we know if the resources we have available are up to the calculation we want to perform? Well, one way to find out is through benchmarking suites. A benchmark suite based on container technology has recently been developed by CERN and has only been tested on a very small number of HPC systems, whose high-level architecture can be seen here in the figure in the slide. The purpose of developing benchmarking suite is to determine different performance that supercomputer within the reach of the four participant entities can have for the development of the high-energy physics and astronomy calculation. Therefore, this is where this project is born. And for this reason, one of the main goals of this project is to study how it works in Surf-Sara, as well as to try to add new types or workflows. Also, to test high-energy physics workloads in new hardware, and finally, to try to combine this benchmarking suite with PRAISE benchmarking tools.
The list of the benchmarks that can be seen in the slide are available in the current version of the benchmark suite developed by CERN, where here HS06 is the AGP-wide benchmark for measuring CPU performance. SPEC 2017 was designed to provide performance measurements that can be used to compare compute-intensive workloads on different computer systems. AGP Score is an application that orchestrates the execution of user-configurable benchmark suites based on individual benchmarkers containers. On the other hand, DB12 and Atlas Kit validation are fast benchmarks that should not be used for performance measurements. Rather, they are useful for quickly test and understand the performance of the benchmark suite. Here at the bottom of the slide, we can find a link to the benchmark suite repository. To run the benchmark suite, here we can see two command line examples that can be used to run DB12, HS06, and SPEC 2017 respectively. Taking this into account, a script has been modified to run different workloads in Surf-Sara using the Slurm queuing system. According to the script and the tests we've made, the benchmark is going to be tested in 5 nodes simultaneously in Surf-Sara. The Unified European Application Benchmark Suite UEABS includes 13 application codes collected by PRAISE and DESA. The list of the 13 programs included in this benchmark suite can be seen in the slide. We have Alia, Code Saturn, etc. As mentioned above, one of the main objectives of this project was the implementation of the Unified European Application Benchmark Suite in the benchmark suite developed by CERN in order to automate it and extend it. However, due to the time available, the complexity of the code and the HPC containerization process, this task has not been accomplished completely. On the other hand, the containers needed to run the applications were found and tested, so the last step needed is just the implementation in the CERN benchmark suite, but this is not a trivial task as we could experience. There's some another examples of the UABS. Regarding the project outcome, and to conclude, Among the tasks fulfilled during this 2-month project, we can find the exploration of the benchmark suite in Surf-Sara, which includes the addition of workflows in different nodes simultaneously, as well as the test of the EJP workloads in new type of hardware, for example, Mare Nostrum 4. On the other hand, we could not achieve the task of combining Praise benchmarking tools with this benchmarking suite. However, given the progress we have made in this regard, we are very hopeful that this task will be soon achieved.